Component 1, in-class question book, question 7, squirrels. Our red versus grey squirrels here. And we are monitoring the population. And what they do is they get a squirrel tube, and then have some bait inside the tubes, and then they've got sticky insides, and these trap the squirrel hairs. What the main advantage of using hair tube surveys to determine population numbers? It's the last mark on the marking, but I think it's one of the most important. Is no harm to the squirrels, so they can just run through this, get the bait, and so on. And other things, you can just leave these, for a period of time. You don't have to watch them, and the data will collect itself. So no need to observe the tubes. You can just leave them, words to that effect. And then other kind of scientific reasons. Does not rely on close observation of animals, which means that you don't have to, you can just use these hairs to identify them rather than having to decide which squirrel is which from a distance usually. And you could use DNA analysis, so you could look at gene pools and diversity and so on. Gene pool analysis. So there's 4 possibilities for your 2 marks, but go for the 2 obvious ones. What do the squirrels actually do? Well, they eat the outside bits of these cones, and they get to the seeds inside. How would you set up a transect? So if we've got an area, here, a transect, so we've got cones all over the place possibly. What we're going to do is sample across there, and you kind of draw a random line across, the usual washing line or something like that, and then tape out. You'll do this on your little field trips. Tape out the measurements, and then sample quadrats along here. You might do it every quadrat, or you like as a belt transect, or you might do it every other quadrat or every 10 meters or whatever, and that's an interrupted belt transect. And then you might do this in different areas. You might do it across there and across there to get any representative spread. So we need 3 marks from this. So at regular intervals, place a quadrat. So belt transect at regular intervals, place a quadrat along the line. Some sort of description of that. Then in each quadrat, what are you going to do? Are you going to count the number of cone cores? So count the cone cores in each quadrat. You're going to repeat this in different areas. we've now hit our 3 marks. And you could say you could do this at, every few weeks as well. So repeat, every few weeks, or some other sensible time scale there for 4th mark. We've got some maths now. So we've got all sorts of little bits of information that we need to put together in a sensible way. Calculate the total energy consumed by the squirrels from the cones, the total. So we're starting off with how many did we collect? We collected 240 cones, and each contains 25 seeds, and each of these contains 0.18 kilojoules. So 0.8 kilojoules in a seed, there's 25 of them in a cone, and we've got 240 cones. So we're just going to times those together. So we've got 240 times by 25 times by 0.18. That gives us 1080 kilojoules. Using your answer from 1 and the information above, calculate the total energy consumed per hectare. Well, this answer here, is, you wouldn't do this to your answer, is 250 meters squared. There we are. So we need to convert that to a hectare. And this answer here is also for how many days? 84 days. So we need to convert that to 1 day. So that's the 2 things that we're doing that answer. So we're getting this answer here, and that's the number in 84 days. So this bit's okay. We're going to divide that by 84 to get it per day. So we're going to divide that by 84, and that would be per day. And then we need to work out how many 250 meter squareds are in a hectare. Well, a hectare is, if we draw out a hectare is an area that is 100 meters by 100 meters. And so 100 times by 100 is 10,000. So a hectare is 10,000 meters squared. So we're just going to come, how many 250s do we go into 10,000? So we divide that by 250 times it by 10,000. So we're going to divide that by 250 times by 10,000. So when we do that, we got 1080 divided by 84, so that's now per day. And we're going to divide that by 250 and times it by 10,000, and that gives us 514. And I'm not going to put any, it would be 514.285, but I'm just going to round that up. Kilojoules per hectare per day. The average red squirrel consumes 550 per day. Calculate the estimated density. Well, we just need to divide that by what a squirrel would use, and that'll give us how many squirrels we've got. So we're just going to divide that by, so 514 divided by 550. So divided by 550 is 0.935. So 0.935. So actually in this one they are happy to use 0.935 or 0.94 or 0.9. So 0.9 squirrels per hectare. Does that make sense? If each squirrel needs 550 and we've only got 514, we've not got a whole squirrel there, have we? Can't feed a whole squirrel. So that makes sense. And a lot of work there for 10 marks.